Thanks for having me, guys. But I really appreciate you being organizing an awesome event like this. I really know how much time and effort it takes, and really good job. Just before we start, I'd like to ask, is someone here in the audience playing buzzword bingo at the moment or during the conference? I think it's always a very funny game to play, but sometimes it's also a little bit on the expense of people spending a long amount and lots of thoughts in coming up some great terms for some complex idea. And especially there is one term that is very often to find in this field, and that is actually one term I particularly don't like, which is big data. So what is actually big data? Is big data about the size? Is big data about gigabytes, terabytes, petabytes, whatever? What does the term big actually refer to? Does it mean great data, or as much data as we can accumulate, or something like that? So actually what I was looking for is for a slightly more useful term, and I'd like to talk about sensible data. So sensible data for me is something that has actual, is not just data, but it is actual information. And so useful information. And this was just something like an idea I had for this talk, and I'm talking a little bit about dealing with sensible data, or in dealing with data in a sensible way. So please bear with me. Well, by the way, my name is Nils. I'm a freelance journalist and consultant. I do all things cloud containers and configuration management and stuff like that. So if you actually do play buzzword bingo, you're probably on a very close match already. I work a lot as a data engineer from an operations perspective. I'm kind of a believer in the church of DevOps, so working together, ops people and developers is something I firmly believe in. And I'm also, I have to admit, an occasional Python user and developer. I have to admit that I was raised with Perl. Is it? Do I have to go now? I hope not. Okay. From time to time, I do some work for Crate.io. I work as a developer evangelist there. And what we do there is dealing with data. So, as I explained on the last slide, I used to work a lot as a data engineer for different projects from different perspectives. And that involved being exposed to lots of different types of data. So is that on the left-hand side actually small data, because you just use commands that have been around for 3 or 4 decades? So, and is something like Hadoop and the whole ecosystem, MapReduce and all the products that are in this ecosystem, is this just big data? And does it actually fit for every need when you have to process data in a constructive way? So actually, I was missing something in the middle. So something that gets the job done, like on the left-hand side, but is probably slightly more usable, but does not come with the complexity on the right-hand side. We are dealing with exploding data today, and I was kind of looking for something that is able to deal with several 100 gigabytes to some terabytes, that is actually able to answer within sub-second round-trip time, and which is for most easy to set up, maintain, and which is also able to deal with increasing data. So that something like this might be, did you figure it out? It is a kind of a top list of the most popular web browsers that access some web server, and well, this is analytics 0.1 or something like that. But this is probably not very sustainable. So I was looking for something more sustainable, but not as complex as the big guys. So if it comes to dealing with data, well, classical databases easily come to mind, something like MySQL, PostgreSQL. So I come from an open source environment, but if you don't care, maybe even some stuff from Microsoft or from Oracle. But those products are pretty difficult if they go beyond a certain point where they reach their limit of vertical scaling. So at some point there is no bigger computer available, or at least not for a reasonable price. And if you come to this point, it becomes difficult because there are options to cluster a classic SQL database, but it actually requires an expert. If it's just adding some read slaves, that's probably okay. You find lots and lots of recipes of doing that in the internet. But if it comes to the more complex stuff, to scale out something like that in a reliable way and a scalable way, that can be done, but it's hard to do so. And then there's all this, all the NoSQL environment. And scaling out is usually slightly more easy in this field, but still it's very hard to actually pick one of those databases, NoSQL databases. Each comes with their own dialect and an API and their own query language and their own concept, and they work all in a different way. And if one actually fits for one specific problem, it is not guaranteed that it also fits for other problems as well. And because actually that's what we invented back in 1975 SQL, to have a kind of uniform way to access data. Well, and we talked about Hadoop and the whole real big data environments already. It's okay if you have actual projects that fit into an environment like this, but if it just comes to determining what are the most popular web browsers for your web server, it probably doesn't make sense to hire a whole IT team maintaining your Hadoop environment and buying a whole hardware cluster for that. So what I'd like to do right now in the rather beginning is doing a short demo. Well, and I'd like actually to install, configure, and launch a database, and not only a database, a cluster database consisting of several nodes. I'd like to enable replication, sharding, partitioning, and I'd also like to add some features for the ops forks as well, installing a web-based admin UI and enable monitoring. So if you try to do that in a classical, say, RDBMS, I guess a skilled team is at least, well, what would you say, some days, maybe a week, occupied with that. And I have prepared a short demo. Let me see. I'm using Docker containers for that. Are you all familiar with Docker containers? Who has no idea how to start a Docker container? Could you please raise your hand? Okay. Okay, then I explain that. That's not a problem. Can you read that? All right. I start a Docker container with a docker run command. And actually, I can just start the create container. The create container is a packaged version of the open source project itself, and that is hosted at Docker, at the Docker hub. And if it's already on my computer, but actually on this computer is nothing installed but Docker itself. And it just caches at the first time I launch this, and I practice the demo 2 hours ago, so we don't need to wait for the download. So now I start the container, get some debugging output, which is kind of not necessary for us, and with a skilled eye I find it's not really necessary, but I see there's a link in here because the Docker container has a private network attached to it, and on this private network the software launches on port 4200. And I just open a browser to that address. Did this work? Probably a little bit small. Yeah, and this is just, it looks very similar to several NoSQL databases as well, but there's an admin link as well. And, okay. I started a cluster before. Let me just shut down the cluster again. So we see actually all stuff. Let me stop that. I have a short script to take care of removing everything. Let's see, okay, now I have a fresh Docker with no images and no containers running. I just repeat the last command. We once again see the boot up messages, and well, actually, usually I directly discard them, but it's very convenient to open a link here and to add the admin URL. Yeah. So what we see here is kind of the monitoring. We have a one node cluster at the moment. You can see it on the top. Can you actually read that? Let me see if I can make this a little bit larger. I have a one node cluster. This is the version, this is the cluster name, and this is the cluster load. At the moment there's nothing in my cluster. Okay, but I promised to launch a 5-node cluster, so I go back to the to my, hold on a second. So as you remember, this is the same command I just ran before. -d means as a daemon. Once again, my password. And I started the whole thing again. Second time, third time, and the fourth time, and the fifth time. And then let's go back to the admin UI. And as you can see right now, at the moment we have 3, and now we have even 5 nodes at the moment. So this results in a short peak in the load, but after a few seconds we are back to normal again. And actually that's it. So we now have a full cluster of database nodes running all on the same machine, which actually makes no real sense in a production environment, but it works. As you can see right now, there are some warning on the right-hand side. I should have unconfigured. It complains about that I did not tell the cluster beforehand how many nodes I actually planned to spin up, because we obviously in a distributed system have to come up with some means of battling against a split brain problem, and it just complains over there. But this is just a single SQL command I could type if my hands weren't tied to this microphone. Yeah, and that's it, and it's up and running. I get some information. Well, I can look here for the cluster. On the there is a tab for each single node. You can see the load in there and the disk usage and so on, which is at this point all the same for all 5 nodes. You see the version. You can even, to a certain degree, mix up the version. So just by adding new nodes to the database means that you can add and also remove nodes to your cluster. At the moment, let me see here, it's tables. We have nothing in our database, but as soon as we populate them, you can distribute the database over the whole cluster, and that completely happens automatically. I have prepared a short example in a few seconds, in a few minutes. Is there something else to show at this point? I don't think so. Let me go back to the presentation. I see. Next time I don't use the beta version of Ubuntu. Okay. Well, a few words about, well, all the features of Crate. I don't need to read them all. The main feature is probably it's a distributed SQL database. So you actually talk SQL to Crate, no fancy REST dialect or something like that. It has all the features I mentioned already: auto-sharding, partitioning, replication. I can show you in a minute. Well, how easy it's to install, I just demo to you. And you can do real-time search, aggregations, and this is probably something that needs some expression, since Crate actually uses all the distributed nodes for those aggregations. So it does not use the nodes just for fetching the data. So as much aggregation as it's possible is done on the distributed nodes, which is a major feature as well. Well, this is all the components. I don't think we need to go to more detail right here. Create implements a masterless shared nothing architecture. What does this mean? And what does this mean especially in a container context? That means that all nodes are actually the same. And there is no specific master in terms of some single point of system you need to contact. So if you have a container environment, as I showed here, I have here 3 container hosts and 1 to 3, 9 total application containers. And you could, for example, launch a create container on each of the hosts, and you obviously have to make sure that they get connected by each other. And so each application container can save its state into the local create instance, which is interconnected with all other create instances, so that you have kind of a, well, an omnipresent persistent layer like a data ether that spans your whole container infrastructure. This comes really in handy if you want to deal with the problem of persisting state in application environments where an application container should be ephemeral and could be discarded at any time. So Create is an open source project and has several components. The blue components are written by Create itself and the Create community, and there are some core parts depend on Elasticsearch, which is actually a basic foundation of Create. But as you can see, Create is not just a layer on top of Elasticsearch. It adds some substantial features as well, as you can see on the graphic. And we have also some other open source projects, for example, the Presto SQL parser, the Netty component, and obviously Lucene, which Elasticsearch depends on likewise. I prepared some demo code. There are drivers available for Create for different programming languages, and if it comes to simple connecting to a database, to a SQL database, this is no real magic, but still I wanted to highlight a few things here. So we have this a driver which is in all repositories that's easy to install. I also use here the Faker factory to create some random data. So for example, the fake last name, you can create good looking last names for different locales and stuff like that. You can also create social security numbers and addresses and URLs and whatever. It's a very interesting project. So if you want to populate a database in a useful way, have a look at Faker. So what we do is we connect to our cluster, we execute, we create a schema, and then we just add a number of records to the database. So, well, I can actually show you that, but there is not much to see. Let me see. I probably have to adapt the, yeah. Let me see. Okay. Well, that's even more easier. We have this play cluster, so everyone can play with in the internet, play, create, IO, and that's publicly available. Please be kind and considerable with your sandbox players. Every now and then we restart this cluster, and I use it at the moment. And so I just can, a nice, no more service available. Probably my network connection is not. Let me change that to the local system. So I just added a sixth node to the container, which is because of the -p flag at Docker, exposes its ports to the host machine as well. So I can address it at localhost, and now my script, well, this is bad demo luck. So if you're actually interested in looking at that, I can show you later on. Actually, it does not do much magic. But there are three things I'd like to point out. If you looked closely, I created a table, if it does not exist, just with a reference integer. And I inserted quite different columns in there. So we have a dynamic schema in create, which can also be turned off. But if you add new fields on the fly, you can do that at any time and without any performance penalty. This comes in handy, especially if you have evolving and changing data definitions, like with adding a new field in your time series data or something like that. And there's something else. I made this connection with a client connect call, and in my demo code there was just a single line. But as we've seen, we now have a cluster of 6 machines, and since we have a shared nothing architecture, we can contact any of those 6 nodes at the moment. And it doesn't make any difference which one, because the nodes themselves determine where does the actual data go, to which actual node should the data go, and routes the data there automatically. That is completely transparent for the user. So if you actually, and you can do this in all clients and also on a command line client and so on, you can have a list of several nodes, and the client just picks one. And if one is not available, it picks the next one and so on. It implements a round-robin schema on that. So that adds both high availability as well as load balancing if you have several connections going to the cluster at the same time. Very important, especially for the people who actually use Create, is inserting vast amounts of data. And doing so can be obviously done in a few different ways. The most simple one is obviously connecting to the database, setting up an insert statement and executing this statement. But obviously this is slower compared to doing actual bulk inserts, as I did here on the lower part of the demo, where you prepare your payload first and then do an execute many with the placeholders and then a whole payload. So usually if we do some benchmarking, we do something like 1,000 or 10,000 inserts in a single bulk statement, and this speeds up everything very much. You can also create directly with JSON. So if you have already JSON data, you can feed it also directly over the REST API. And if you have different file formats, we have added a new feature that you can write specific plugins that parses that data directly. And the client itself is not at all involved in dealing with the data. So the server itself fetches the data, say from a S3 store or from an HDFS or from some other data stores, if you have vast amounts of data for that. Well, there are some caveats, especially about retrieving. You probably know the CAP theorem, consistency, availability, and partition tolerance are three major properties of distributed systems, and unfortunately, you usually can only pick two of them, and you have to deal with some limitations on the third. And for example, create implements eventual consistency, which means the database is consistent, but it is not guaranteed at which time. So in production it just takes a few seconds, and after that you have the same state, the same consistent state on all nodes. That is, the consequence of the CAP theorem. We have also, once you read data after you wrote it, you have also consistency and a guarantee that once the data is once read, it is consistent in subsequent queries. So if you actually need high performance, it's very important to have a very well thought data architecture, because that dramatically affects the overall query performance. But if you do so, you can achieve astonishing performance values. You should avoid complex joins and especially transactions. Transactions are not implemented on a SQL level, but need to be implemented on the logic of the application itself, if you really need them. But in most situations, it is not really necessary. I don't know if you know this paper from, I think it was someone from Amazon who came up with this term of the eventual consistency. It's a very interesting paper to read. Yeah, and well, something creates a good match is when you actually combine it with data exploring and visualization tools. And the project just recently added a couple of new tools in there, and I think they will get released soon, so that you can actually do some graphical browser-based exploring and drawing cool pie charts and stuff like that. Well, some final notes on performance. There are actually users that use Create in a production environment. They run up to 100 nodes in a cluster. We actually set up a cluster with virtualization and containers with about 1,000 nodes. If you really plan to do something like that, contact us so that we can support you, because we found out that container virtualization is still something complex to deal with, especially at those scales. But it worked. So some people actually store trillions of document blobs there. They insert more than 3 billion a day. Or, well, our high score was at the moment inserting 4.5 million records, lines per second in a cluster, and that was not even a 1,000 node cluster, but I think a couple of 120 or something. Yeah, and this is just a summary of probably everything I taught you. So for developers, it's nice that you can use SQL for storing your data in a database. Python drivers are available. There are several ORMs available also for other programming languages. It's easy to integrate with existing solutions with some sensible thought about this. You can also use some other features I did not mention so far from the NoSQL world as well, schema changes, and so on and so on. And obviously, it's also very useful for admins and operations folks like me. There are several forms of installation. So thank you very much.
Thank you, Nils. One more comment?
No, I just wanted to ask if there are some questions.
Exactly.
Do we have?
Yes, we have, well, only 2 minutes left, I'm sorry.
Okay.
Is there any question in the back? Yes.
Hi, thank you for the talk. I have 2 questions. First one would be, would you consider create more an OLTP or OLAP database? And second one, did you run any benchmark? Because there are standard benchmark like the TPC ones, the TPCH for example, and it would be interesting to see results of that.
I start with the second one. We actually do frequently benchmarks, but as we all know, benchmarks are a difficult topic. But have a look at our blog, where we just recently published a few numbers. But this is an ongoing process. And we add more and more stuff in there. So if you're interested in some specific scenarios, reach out to us, and we always try to reproduce that. What was your first question? I'm not sure if I got it that. Oh, I'm sorry.
No problem. Would you consider it more like an OLTP, so like transaction-based database, or OLAP, so more for analytics stuff?
Well, it depends actually on your use case. We have very different use cases. As I explained, there is no consistency guarantee all the time. So it's mostly useful if you have some streaming data that you actually write into the database, and then you can do analytics on top of that. That works very well, and especially works with awesome response times. But it depends on the level of consistency you actually require.
Any more? Right.
Anyone else?
No. Any more questions?
Over there. Okay.
Okay, it's coming.
Thanks for the talk. Just a small question. Do you think this is production ready or something in development? Would you recommend it for a production system? At which level you think you are of maturity?
For sure.
Okay.
No, well, seriously. There are companies using this in a production environment at the moment. So, for example, there's a company who has vast amounts of logging data. I think they're providing a security service for their clients, and they're collecting, I think the numbers have been from them, at least the first one, the 4 billion records on a day. That's, I think, a 2 or 3 digit gigabyte number. And they do extensive analytics on top of that, and they use this in production.
And one
over
here.
there.
Thank you for the talk. Just a quick question about how you mentioned that the query performance is heavily impacted by the data schema. Do you provide some guidelines how to turn a normalized schema into some denormalized schema which will perform great on your database?
Yeah, there is no general answer to the actual question, but we have a lot of use cases we described on the web page, on the blog, and if your use case is not in there, let us know, and we always are very interested. We are just we started 2.5 years ago, and so we are very interested to find out what others are interested in, but with some tweaking we so far have solved every challenge so far.
I think that was almost the last question. The very last one is over there. And then we go to coffee break.
Hi, thanks for the talk. For a while you weren't supporting join syntax and join queries. I think you introduced that recently. Can you share any benchmark information or data on that? Because Elasticsearch only has parent-child relationships, so I was wondering how you guys solved it, and are there any results you can share?
So it depends on the type of the joins that you actually perform. Not all are supported, and I have to relay you to the actual developers, because I don't know about all the details of all specific join types out of my head. I think we did not do extensive benchmarking on that, but that is on the backlog, and we certainly should do that. The thing is, some of the joins are cheap and some are expensive, and the expensive ones will ever remain expensive, and one could argue, if you really need them, if then this is the right solution, or if this is the right approach to use a distributed system like that. But very small changes in the query can dramatically affect the overall performance, and sometimes it just takes some denormalization or something, and a simple tweak like this, and if you add some extra knowledge to your data schema, you can speed up dramatically. But
Okay.
if you have something, once again,
Exactly, that was my
this,
suggestion. Let's continue the discussion then in the coffee break.
Yeah.
Thank you very much, Nils.
All right.